We meet again, students. Here we go. We're starting off chapter 10, talking about this thing called the Pythagorean theorem. What is the Pythagorean theorem? Here it is in words. It says any right triangle, like this one, it's a right triangle because it's got one of those little symbols. That means 90 degrees. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. What? Here's what's going on, friends. So the two sides that are connected to the 90 degrees, those are the legs of a right triangle. Okay, I guess that's a single leg, excuse me. So that's a leg and that's a leg. Together, these are the legs. And then this is the 90-degree angle. Now, for some reason, they decided to name this longest side. This is called the hypotenuse. Okay? Hypo 10 U's. Okay, that's how you spell it. Okay, it's kind of weird. The relationship is this, okay? Right here. The legs, if you take the legs and you square them, leg squared plus leg squared, that's going to equal the hypotenuse squared, okay? No matter how you make a right triangle, this relationship always, always, always happens, okay? So you take the legs, you square them and add them, that's going to equal this dude squared. So we're actually going to use that to solve for missing pieces. If you have two of these three, you can always find the missing piece, okay? So if you're given the legs, you need to find the hypotenuse. Here's kind of the shortcut. You take the legs, you square them, you add them, and then you root them. That's kind of what I say. It's my little saying here, but I'll show you how it works. So I'm going to kind of sketch one here from scratch, okay? So let's say we have a leg of, I don't know, how about 3 and a leg of 4, okay? What do? So 3 and 4 are the legs. How do you know they're the legs? They're connected to the 90-degree angle. So I'm going to take 3 and 4 right here. I'm going to square them. I'm going to add them. And then I'm going to square root that whole thing, okay? You square them, add them, and then root them. So you can actually do this whole thing in your calculator or one move at a time, okay? So 3 squared is 9. 4 squared, I don't have all this noise in here, excuse me. Let me get all that stuff out of the way. That looks like quiz questions. Uh-oh, spoiler alert. Okay, and I'm out of focus here. I'm not sure what's going on. Come on, focus. Focus, please. Thank you. Okay, you can take the 3 squared plus the 4 squared. Okay, you can do it right there. Sorry, that's kind of out of focus. I don't know. It's not wanting to focus on it. Okay, that's 25. So then you got to square root that. That's what the hypotenuse squared equals. So you got to square root that. So second square root 25, boom, 5. Okay, so this whole big bad thing right here equals 5. I'm really sorry that the focus is not being nice to me right now. I apologize. That's what I get for using my cell phone. There we go. So it's 5. That's it. This hypotenuse has got to be 5. So whatever the label is, centimeters, inches, it doesn't matter. Okay, that's 5. That's it. That's the process. You take the legs, you square them, you add them, you root them. I should be able to do that whole thing in the calculator at once. Let me give it a try here on the side so I don't mess with your heads. See? Okay. Look at that. Instantly calculates. Pretty simple stuff. Okay. Now what do you do when you have the hypotenuse and you're missing one of the legs? Okay. So I'm going to sketch a very similar one. I'm going to make up some different numbers though. Let's say that this leg is, I don't know, 13, and then this hypotenuse is, how about we make it 22. There you go. Just kind of making some numbers up here on the spot. Okay. Hypotenuse and a leg. We're missing this leg. What do? So you square them, subtract them, and then root them. Now the big thing here, over here the order didn't matter, okay? Over here the order absolutely matters. You should always start with the hypotenuse. Since it's the biggest piece, start with the big piece. Big piece minus a small piece should equal the other piece, if you think logically, okay? Square them, subtract them, and then square root it. So I should be able to do the whole thing in my calculator one move. Now with these, round to the nearest tens place, that'd be fine with me. Square root 22 squared minus 13 squared. Hit it. So about 17.75 or 17.7. I guess we'll go to the first decimal today. So about 17.7. There you go. Done. That's it. It's rinse and repeat, friends. Okay. It depends on what you have, though. It's the same kind of structure. It just depends if you're going to combine them or if you're going to subtract them. If it's the legs, square them, add them, root them. Okay. And if it's the hypotenuse in a leg, you always have to have at least 2. Then you subtract them. Again, make sure you have the hypotenuse minus the leg, okay? Because if you try to do it the other way around, your calculator is going to screw it up. Even if you accidentally typed it in wrong, your calculator can't do a negative root. So if you go 13 squared minus 22 squared, you should get a negative. So you're taking a small number minus a big. And if you do that, so if you mess up, the calculator will tell you that you messed up. Okay, there you go. That's the basic Pythagorean theorem. It should take you a matter of seconds. This is a huge deal when it comes to geometry. So we're really going to hammer this in chapter 10. Okay, goodbye.